This video is about evaluating expressions. Here's a sample problem. Well, here's the expression, which is just a bunch of math symbols put together. And when we say we're going to evaluate it, we mean we're going to turn it into a number or give it a value. So since they've told us that x equals 5, could I simply replace x with 5? Yes, but be careful. We don't want to interpret this as 3 plus 25. Let's remember that whenever we put a letter and a number next to each other, we mean that number times the value of that letter. So 2x automatically means 2 times x, even though we don't write the times sign most of the time. Now to evaluate this when x is 5, I'll simply replace x with 5 and work out the expression. Let's not forget to use the order of operations, you may know it as PEMDAS, which tells us that multiplication comes before addition. 2 times 5 is 10. And having done the multiplication, I can now do the addition. 3 plus 10 is 13. And that's evaluating an expression. Let's take a look at another example. If we want to evaluate x squared when x is negative 3, we'll replace x with negative 3 and work out the value of this expression. Let's not forget that an exponent of 2, or to square something, means to multiply it by itself. And therefore, negative 3 times negative 3 would become positive 9. Let's not forget, a negative times a negative is a positive. In comparison, let's look at another problem with an x squared, and at this time with a negative in front of the x squared. Negative x squared is one of the most misunderstood expressions in math. Some people think it means that x is negative. Some people think it means that you're squaring a negative. Logical thoughts, I suppose, but in reality, negative x squared means, by definition, negative 1 times x squared. We don't write the 1 and we don't write the times sign normally. I've done that here just for you to see how easy this expression is to evaluate as long as we keep in mind what negative x squared actually means. Given that x is 7, I can replace x with 7, and now just use the order of operations to simplify and get a final value for this expression. As you'll recall, exponents come first. 7 squared, meaning 7 times 7, is 49. And now, let's not forget that a negative times a positive is a negative, and therefore negative 1 times 49 is negative 49. And here's our final example, a slightly larger polynomial here than we've been seeing. We want to evaluate this when x is negative 4. Notice there's 2 x's in the expression. So replacing both of them with negative 4 will help me achieve what I'm trying to do here. But I now have a lot of math to simplify to get a value for this expression. So as usual, I have to use the order of operations, or PEMDAS, which lets me know that exponents come first. Negative 4 squared, meaning negative 4 times negative 4, is positive 16. After exponents come multiplication. Here's my multiplication. 2 times negative 4 is negative 8. But notice I now have the subtraction of a negative. Let's not forget that subtracting a negative is the same as adding. And finally, I can add these numbers together and simplify and get a final value of 29.